guidance and coordination. And hello, everybody. I'm Francesca Visi. I'm a marine geologist here in Italy. And my role now is to introduce to the first and second ocean literacy principle. And mostly because they have to do with rocks and what is the container of the water of the ocean. So what I would like to try to guide you through this first part of the ocean literacy guide. As Yolanda said, the first principle has to do with, let's say, one main concept. I don't know if this part here is hidden or is visible for you, because maybe you cannot read the title of the first principle. And the first principle is Earth as one big ocean with many features. This is a very important sentence because it has to do with the characteristic of this environment, and also on the relationship that this environment has with the geosphere. So let's say the rocks, not only rocks, but mostly the hydrosphere. So not only the ocean water, but also the other kind of water, so fresh water, but also atmospheric water or water containing the atmosphere. It has to do with the biosphere, and it has also to do with chemosphere. So all the systems are connected, and we will try to explain how they are connected and how to cope with this very complex system. No, così non va, così va, così va. Okay. So the first principle has to do with the, let's say, four main topics that you can find on the framework, the scope and sequences framework that Yolanda showed you before. And the four main topics are geological features, that has to do with the characteristic of ocean floor and the plate tectonics. And it has to do with the ocean water properties. So what is the content of this container? And so the characteristics that are peculiar, and so they have to do with salinity, temperature, and pH conditions. And the other topic is about the circulation of the ocean. So how this mass of water circulate across the different basins. And it has to do with the sea level concept. And sea level concept, I think, is one of the most important. And even if it seems not so important, it has to do with our daily life more than we can expect. So for the, let's say, starting for the beginning, some of the concepts are talking about the ocean is the defining physical feature of our planet Earth, covering approximately 70% of the planet's surface. And there is one ocean with many ocean basins. I use this video animation just to show you what most of us may remember from our study, that the Pangea and the Panthalassa, so all land and all sea, this can be useful to explain and to visualize how the ocean is just one big ocean and with pieces of land across it. But if we use this projection, this picture that is being developed by a person called Spielhaus, the name of this projection is Spielhaus projection, is a way to see our planet from the point of view of the ocean. So one big ocean and the land is around it. And you can see the different basins that we are used to call oceans, but in reality, they are part of the same ocean. And but this principle have to do with the also with the characteristic of the ocean floor, and the ocean floor characteristics are determined by one of the most important, let's say, process that is acting on the Earth's surface, that is the plate tectonics. So I don't know if you ever heard about it, but is a kind of theory to explain how our external part of the planet, so the crust, the lithosphere, is behaving. So is this interaction between the different plates, the different part of this lithosphere, makes the shape and morphology of the ocean very irregular. So if we take rid of the water of the ocean, we can see the floor, and we can see that it's very rough and is very similar to the land surface. So in reality, it's a kind of surface covered by water. And if we want to indicate the depth of the ocean, we can use the bathymetric maps. That means that we calculate the layer or the levels from 0, that is the sea level, going down, so below sea level, and they are called bathymetric lines or isobath. And plate tectonics is one of the most important concept and process to learn about. So you can introduce at school in different ways, but depending on the level of the teachers, of course, or the pupils, you can use different schemes. This is one of the many schemes you can find online, and this is a very summarized scheme of all the systems. So it's how the plates are behaving one against each other. And that determines the way the seafloor is made. So the ocean floor is composed, the ocean bases are composed of the seafloor and all of its geological features. So island, trenches, mid-ocean ridges, and rift valleys. And they vary in size, shape, and features due to the movement of Earth crust. So just due to the plate tectonics. So what is the difference between the land and the ocean surface? Is that the land is, we have air on top, and in the ocean we have water. So this changes a little bit the processes that act in these systems. So the slopes are gentler than on land, but the highest peaks, the deepest valley, and the flattest vast plain are all in the ocean. And we can have a different way to see the seafloor. This is a kind of, let's say, vertical cut. If you imagine to cut the ocean across all the oceans, these are most of the, let's say, a scheme of the main features, and they depend on their shape, but also on their depth. So there are names that are given according to the depths of this part of the ocean, and also to their shape. So we can have volcanoes, we can have ridges or mountains, we can have valleys or trenches, we can have plains, we can have slopes and shelves, and so on. But we can also show it as a landscape, but in this case, we call it seascape. So as a kind of panorama of what is underwater if we take rid of the water. So it's very interesting. If you can use different sketches or schemes you can find online, and they are very, are summarizing all the features that are on the ocean, but you can also explore your own ocean or the ocean more closer to your home or to your school by going to Google Earth and visualizing the sea floor or the sea basin closest to your school. Another important issue and concept about contained in the first principle is about the water properties. So the water properties of the ocean are special and specific, but they are not so uniform, even if we give average values usually. But the most important thing is to learn and to remember that 97% of the water on Earth is in the ocean. So the part that we use and that is useful for the life is a very small percentage. And here you have a scheme. It's a very simple one. You can find it in the different languages, and you can start to introduce this, let's say, quantities or percentages of kind of water to your pupils. And you can also develop some quiz about that. And they are very useful to make the people aware about the distribution of fresh water and seawater on our planet. And the characteristics of seawater are defined by 3 parameters, that is salinity. So salinity means that we have salt in the water, and the water is salty for more or less 33 per mil, so 33 part per million. And this determines characteristic of the seawater, so that the behavior. So the freezing point is slightly lower than fresh water. Its density is slightly higher. Its electrical conductivity is much higher. Sorry, and it is slightly basic. But we have not only just one kind of sea salt, for example, that not only the kitchen salt, let's say the cooking salt, but there are different kinds of salts. So it's interesting also to understand what kind of salts and what are their characteristics. The other parameter, and we can also define what are the different kind of water. So there is not only the, let's say, ocean water, but we can have different kind of salinity, so with different kind of water according to the content of salts. So this is a kind of distinct, let's say, a classification of the water linked to their salinity. Another important characteristic of the seawater is the pH, and here is written not correctly. The pH is written like this, so this is my mistake, sorry. And the pH is a kind of acidity or basic or alkaline characteristic of a liquid or of a substance. And we know that the seawater is around 8.1, so is here. And this is very, very close to the human blood pH. And we can see also that, for example, what is in our stomach is here is very acidic, and the seawater is now becoming more acidic. You maybe heard about acidification, and that has to do with a lot of processes acting in the water. So this is another point that is important to understand and to explore at school. And this is very nice, and there are a lot of simple experiments you can do in the school. So the third parameter has to do with another topic that is about the circulation of the ocean. So the ocean circulation is determined mainly by 2 things. One is the shape of the container, so how the seafloor is made, how the ocean basins are made and are connected among each other, and depend on the characteristic of the water. So on the density, that is to do with the content of salt, so the salinity, but also on the temperature. So we have this main circulation system across the ocean that is called the conveyor belt, and is due to the thermohaline characteristic of the water. So the temperature and salinity that determine the density of the system. So the global ocean conveyor belt moves water throughout all the ocean's basins, transporting energy and matter and organism, of course, around the ocean. And the changes in ocean circulation may have a large impact on the climate and cause changes in ecosystems. So again, I prefer to show you the conveyor belt in the Spielhaus projection, because it is more, let's say, evident how they are connected. And in red, you can find the surface current. In blue, you can find the deep water formation and deep currents. We can also have a study or understand or explore the vertical distribution of masses due to density.
Francesca, 3 minutes, please.
Okay, thank you very much. And this is an example for the Mediterranean. You can see there are different water masses, and they are influenced by the salinity, but also by the shape of the seafloor. But you can also have, this is another picture about the North Atlantic circulation. This is a more complex picture. Maybe you need some time to understand it, but you can find different water masses, and they are defined by their different density. So salinity and temperature differences. So the circulation is also that it is an integral part of the water cycle and is connected to all of the Earth's water reservoir via evaporation and precipitation. So the ocean is part of the system, but I would say that is the most important part of the system. And is connected to all the freshwater systems, so that is on the surface and the subsurface or underground water. And since it is connected, it transports water and material and salts and nutrients and also pollutants from the land to the sea. And one of the most important issue now for the ocean management and conservation is the pollution that is chemical, but also by macro remains and mostly plastic. And this is brought to the sea by the rivers. And we have also currents, and you can see many sketches with currents that are circulating more or less locally across the ocean. These are mostly surficial currents in this picture. And you have waves. We have different kind of waves that mix the water in different waves according to the seafloor and the two characteristics of the coastline. And we can have tides. And tides is another motion of the water determined mostly by gravity issues. That is, one is the most famous is the moon influence on the ocean. And the last but not the least is the sea level. And as I told you before, the sea level is most important because it's a reference level for our topography, our calculation of altimetric and bathymetric measures for all our measures that are referred to the Earth's surfaces. So the reference level is the average height of the ocean relative to the land, taking into account differences caused by tides. Here you have a reconstruction of the post-glacial sea level rise, is a kind of extrapolation of many data that have been put together to have this reconstruction from the 24,000 years ago to up to today. And we have a lot of oscillation of this sea level, and they have a short range in time and space or a long range in time and space. So we can have short oscillation, we have seen them before, and we have a wide amplitude oscillation. Can be the interglacial and glacial oscillation, or what is happening today because of the melting of many of the glaciers.
Half a minute.
Okay, so these are the two, for example, the two examples of the two polar area, and the difference of the melting of the north caps instead of the southern caps. It has different implication on the oscillation of sea level. And this is a trend this is a map produced by the European Environmental Agency about the trend in absolute sea level across Europe. So what was going on, because it is calculated on past measurement, and so we can see that the sea level is growing, but not the same in all places. So this is the last part that I wanted to show with you, that it is a big ocean, but it's not infinite. And so we have to take care of it because we have a large and very important impact. And our colleagues will talk about it in the next presentation of maybe next Tuesday. So here are very simply the scope and sequences flow diagrams, just to have the example, but Yolanda already explained about them. So these are some schemes that can help you to bring these topics to the school, and the different topics and subtopics you can work on it. I would like to say something that is just, we have also an earth science literacy principle. So there is also this part that can be explored. And there are some principles here, like in ocean literacy. And some of them are linked more or less with this principle. And I will take advantage for the principle too. And these are some of the UN decades goals that are dealing with the Principle1. So just some suggestions to link the topics and the informations. And this is about the mission areas. So what is doing Europe for our present and near future, and particularly what has to do with the ocean floor is that one of the idea is to build the digital twin of the ocean. So this is one of the main project, let's say, that is a worldwide project, and Europe has planned to do its own part.
Okay,
so here are some
Francesca.
examples of activities and some labs that you can do by reconstructing the seafloor. So this will help to visualize the concepts.